All right, so I'm going to take a moment to share my screen with you guys. I want you to have your agendas out, please. And you guys are period 5. And we're going to talk about what it is that you're going to be doing this week. You can write the information down in your agenda, but please realize that besides it being in your agenda, if that's where you're writing it, it will also be in the calendar that is on your Canvas. It's also going to be on your to-do list that is on your Canvas, and it will also be emailed to you. So you will have 4 places to be able to get that information. Do you have a question, anyone? All right. So this week, you guys are going to be talking about and learning about lab safety and tools of a scientist. And I know this looks like a lot, but trust me, when I show you what it is, you're going to be like, oh, that's not terrible, because it really isn't terrible. You have a lab safety overview. You're going to read about lab safety. And again, we're in module 2. So for Monday, which is today, you're going to look at module 2.1. 1A, 1B, 1C is for Monday. Module 2, 2A, 2 is for Tuesday, so 2A is for Tuesday. This requires your parent or guardian's homework also. They're going to have to do this with you. Module 2.3, 3A through H is due for Wednesday. And again, don't have a cal. Once you see these, they're really easy. They're going to be a minute each, I promise you. Thursday is 2.4, A through E. And these are just videos, most of them. And then Friday is 5A, 2.5A. So if it's 1 ABC, Monday, 2A, Tuesday, 3 A, B, C, D, E, F, G, H, Wednesday, 4 A, B, C, D, E for Thursday, and 5 is for Friday. Now I know it looks like there's a lot to do up here, but take a look. You're going to see in here, one of the pages is going to have a video about science safety symbols, right? You have a couple of videos there. About what these symbols all represent, right? Here's your skull and crossbones, that's poison. And then you're going to have to do, it's really easy, guys. This picture, it says, I protect your eyes from harm. And you're going to have to answer what that's a picture of. Second one, I can put out fire by rolling around you. The answer is right there. Okay. So these are fairly simple. They shouldn't take more than a minute each. And keep your hands away from harmful substances, right? So that should be fairly quick for you guys. I know it looks like a lot, but the reality of it is that it is not a lot in here, okay? Because I know people are going to start freaking out thinking they have so much. Don't think that you do. So that's what you're going to be doing this week. Now, in order to be able to get to the next assignment, you have to go through each one sequentially. Okay. Does anybody have any questions? I heard somebody unmuted for a second. Anybody have any questions? No, we're good. Okay. So let's talk a little bit about laboratory safety first before I go into showing you things. Laboratory safety, you guys have worked in a laboratory before in school. I know that you did, you guys did a cell lab. You guys did a lab with water droplets on a penny. You did multiple labs last year, right? I want you to type into the chat what you think is the most, not the most important, but what you think some lab safety rules are, besides wearing goggles or safety glasses, because I know everybody puts in safety glasses or goggles, but I want you all to put in something into the chat for lab safety, laboratory safety. Clean workspace. Awesome, Parker. That's a great one. Gloves, yes. Don't type gloves anymore. What else? Okay, Zio, that's like the most important one on there. Wash your hands, yes. Don't play with chemicals, good. Read the directions. Lynn, that's like the most important one, yes. Protective clothing, good. Reading directions, absolutely. Wow, 5th period. You guys are good. What else do you have? I've not heard from everyone. Juliana, Cyan, Alexander, Alex, Kylie. Althea, I think all clothing is flammable. So you have to wear clothing when you're working with fire. However, try to be more specific about the clothing because all clothing is flammable. Some clothing is more flammable than others, absolutely. Aiden, awesome. Never eat or drink anything. Don't play around, no horseplay, absolutely. Don't eat or drink. Okay, so Althea says not wearing long-sleeved clothing. You're right, because if I have clothing that hangs, it can easily catch fire. Besides clothing catching fire, what else can catch fire? I'm going to say girls primarily, but yes, thank you, Althea. Don't mess with other people's supplies. Hair. I mean, boys with long hair have to tie their hair back too. Good job, Kylie. You had it in there. Excellent. Paying attention to the instructor. Absolutely. Keep your hair tied back. You don't want your hair catching on fire. Okay. And you don't want it dragging through the chemicals or anything like that. So now we have, no, that would not be fun. Let's talk about what you would see a scientist wearing in a lab besides possibly gloves and goggles. They might wear a lab coat. Okay, so that's to protect their clothing. Absolutely. And if you are a scientist and you are out working in the field, what might you have on? Okay, Ashton. What might you have on if you were out working in the field? Let's say I'm going to explore a volcano. What might I have on? That's something that I'd really like to do. I have no desire to go to Hawaii per se, but I would like to hike on a volcano. And I can't hike on a volcano with my sneakers. Maybe a mask because of the chemicals, yes. What else? Boots, absolutely, Arden. And especially if I was to, a heat suit, yes. They have specific boots that you would wear if you were by a volcano, right? And there's lava. Face shield, hazmat suit, absolutely. So there are a lot of different pieces of science safety equipment that we have. Boots, yes. Okay, so we talked about safety goggles, a jacket, some type of lab coat or an apron to cover your clothing, pulling your hair back, gloves, possibly boots, depending on where you are, wearing tight-fitting clothing so nothing's hanging, right? No horseplay in the laboratory, keeping your hands to your own materials and not messing around with other people's materials. Somebody mentioned something about chemicals. Oh, you guys said no eating or drinking. Absolutely. Unless the instructor tells you it's okay to eat or drink, then you can. But there are a lot of labs that I like to do that involve food because I love food, and you can eat those labs, but you would only eat them when I tell you it's okay to eat them, right? You don't ever want to be eating while you are doing a lab, because the chemicals can get into your food or your drink, right? And that could be really bad. So we have no eating or drinking. And one of the other things that I want to talk about, I need my handy dandy. Okay. Okay. This here is a beaker. If I have chemicals in it, I do not want to go over to it, pick it up and go to smell it. That would be really bad, because there might be chemicals in there that will burn the nasal passageway or have toxic fumes in there. So what you want to do is you want to waft the chemicals towards your face, right? You don't want to, oh, it smells so good. No, that's not good. You waft the chemicals towards your face to see what kind of odor it has. No, Serena, not in science. Sorry. Okay, so that being said, now that we've gone over some of those lab safety rules, let's talk about items that we can find in a laboratory. So our lab tools, something scientists use while in a laboratory. And I'm going to show you the first one that I just took out, right? And it comes in multiple sizes. Does anybody know the name of this? Type it into the chat. I think I just said it. Yes, it's a beaker. The beaker has a pour spout, so you can pour liquids out of it. On the side of the beaker, it also has a measurement. It has multiple measurements over here. Whenever measuring in a science classroom or a science lab, you are going to measure in milliliters or liters if it's a liquid. If it's for distance or length, you're going to use meters. And if it's for mass, you will use grams, because we use the metric system when it comes to taking measurements in the science lab. Okay, so I can't right now. Hold on a second, guys. Okay, so our two beakers, you can take measurements from the side. They hold liquids, they measure in milliliters. However, the measurements on this are not completely accurate, okay? If you wanted to get something that was accurate, you would use this tool right here. Does anybody know the name of this tool? Type it in the chat if you know what it is. It's not a tube. I'll talk to you more about it. Hang on a second. If, not the test tube, nope, not yet. If when you finish high school, what do you do at the end of high school? You graduate. That's your clue. It's not a gradual, it's a yeah, smiles, good. This is a graduated cylinder. So graduated cylinders also come in all different sizes. Okay, these are our graduated cylinders right here. Graduated cylinders have measurements on the side of them. You can hear them, they're ribbed, okay? So you know that they're there. And they take measurements of liquids, okay? These are extremely accurate, and they also help us, besides taking measurements of liquids, they help us to take measurements of irregularly shaped objects, which is something that doesn't have a length, a width, a height, a base. If I were to find the volume of a cube, I know that I could do length times width times height, correct? But if I want to find the volume of a rock, which is irregularly shaped, I would need something like a graduated cylinder to do that with. We use something that's called water displacement. Does anybody know what water displacement is? Water displacement. Okay, let's talk about this. I'm going to assume that everyone knows what a bathtub is. If I put water in the bathtub and then I get into the bathtub, what happens to the water? Aiden is, okay, now he's gonna type it in. The water rises, yes, Miles. Aiden was saying that with his hands. I was watching him do this and his, yeah. The water is going to go up. That is called water displacement. When you put something into water and then it rises, that's displacement. So let's say I have 10 milliliters of water in my graduated cylinder and I put a rock in and it goes from 10 milliliters up to 30 milliliters. How many milliliters is that rock? If it's at 10, and then water displacement has it go up to 30, okay, some of you have answered yes, 20 milliliters. You would take the difference of the two numbers. 30 minus 10 is 20. Good, Althea, I'm really glad that you put milliliters in there as well, because if you don't put your unit of measure, then it could be 20 apples. It could be 20 moons, but you have on there 20 milliliters, yes. Okay. All right, so that's our graduated cylinder that is used to measure the volume. Let's talk about these three things. Anybody know what this is? Liquids go in the side of it. Write in the chat if you know what this is. Yes, Miles, all capital letters. Don't yell at me. This one is the test tube. Good. Okay. The test tube is to hold chemicals while we're doing an experiment, right? Now let's say I don't want to carry my test tube in my hands, maybe because I want to heat it over a flame, right? I would use this tool right here. It opens and closes around the test tube itself. Does anybody know what that is called? Not a test tube holder, no, not tweezers. I have tweezers, I can show you tweezers. It's a test tube clamp, test tube clamp. So it's gonna clamp down, see how it opens and closes onto the test tube. And I'm gonna be able to hold it over an open flame. Why would I do this instead of just this? Yeah, this would kind of be stupid, right? Okay. You don't want to get burned, right? Also, please notice that I'm holding it on an angle and away from my face because I don't want anything to shoot out at me. I don't want anything to burn me, right? You don't want to burn your hand. So that is your test tube. You're going to hold it at a different angle. Besides the test tube and the test tube clamp, I have this in which I put my test tube. Hold on one second, guys. So here I am. I can put my test tube into this. It has openings on the top and little divots on the bottom that can hold the test tube. Do you know what this is called? And it's not a test tube holder. Yes, Travis, this is a test tube rack. You can put multiple test tubes in here, right? So you can do the experiment, and you're going to do an experiment in 8th grade in which you're going to have like 8 test tubes lined up, one next to the other, so you can look at them and look at the chemicals inside of them and see different color changes. Does anybody know why we have these dowels on the test tube rack though? No one? Okay. When it comes to the test tube and drying the test tube, you don't ever want to shove so it stays up. I don't know what it is, Alexander. You don't want to shove towels into the test tube because they'll get stuck in there. So instead of, keeps the test tube from falling after you've washed it. So here's our test tube. We've washed out the test tube. It's clean. Now we want it to dry. You turn it upside down and you let it air dry. You don't ever shove anything down into the test tube like a towel so it gets stuck. Okay, yeah. That's the test tube rack, and test tube clamp. Here's an easy one for you guys. What is this one? Yes, Aiden, good job, Isaac. Lynn, yes. That is a thermometer. Now in the science classroom, we're not going to use degrees Fahrenheit. We're either going to use degrees Celsius or Kelvin, okay? So Kelvin is used for extreme cold or heat. Celsius is something, maybe if you guys are interested in becoming an airline pilot or something, being a doctor, being somebody in the medical field, degrees Celsius is used, and not degrees Fahrenheit. Excellent. This one here. You know what that is? Yeah. Good job, Miles. Yes, Lonnie, awesome. It is a Petri dish. So, does anybody know what a Petri dish is used for? Yeah, I'm going to talk about that in a second, Alexander. To keep bacteria in. Yes. No, actually, Isaac, we don't use this to look at small objects. We use a microscope to look at small objects, to examine things. Okay. So let me talk about this, and then I will talk about, it's called a Petri dish. And then I'll talk about degrees Celsius and the metric system. A Petri dish, a long time ago, when I was younger, I would get strep throat often. And I would go to the doctor and he'd swab my throat, right? And you guys still do that. If you go to the doctor, they'll swab your throat. But they take that swab and they put it in a sleeve and send it off to the lab now. But 30 years ago, they didn't do that. 35 years ago, they would take that swab from your throat, and in the Petri dish would be something called agar. Agar is a very like gelatinous, yes, Juliana. Agar is like a very gelatinous, thicker kind of material. You can still poke it. You don't want to poke it. But what the doctor would do is he'd take that swab of my throat and then rub it along the agar. He'd cover the Petri dish and send it to the lab or put it in an incubator and wait to see if any bacteria grew. If bacteria grew on the agar, then I had a bacterial infection. If I had a bacterial infection, then I would have to take antibiotics. So Petri dishes are used to grow bacteria and germs of that sort in them. And yeah, they're used primarily in laboratories. So Lynn said that, you know, it depends on what you're looking at. Sometimes you would use the Petri dish. As far as Celsius, Alexander, the metric system involves degrees Celsius, liters, meters, grams. Those are all measurements, whether you have a kilometer or a centimeter, right? It's still a meter because it measures distance. Everywhere else in the world but the United States uses the metric system. If you look at cars, they have miles per hour, but they also have kilometers per hour. If you go into another country, everything is going to be in the metric system. In the United States, anybody that's in the medical field will use the metric system. So like if you go to the doctor's office and you look at your chart, you'll see your weight in there. You'll see your weight in there in not in pounds and ounces, but you would see it in grams, kilograms, right? That's universal. Everybody else uses a metric system but the United States. So you'll see things in meters, liters, and grams. Does anybody have a like a Dasani water bottle or an Aquafina water bottle, if you look at the side of that bottle, oh, okay, you have that, Miles, that's awesome. And over your left shoulder, Miles, you also have a hydro flask. Can you get that? Yeah, okay. So the water bottle that you have, you don't have to hold it, but yeah, put it down for a second. The water bottle that you have, if you look at the label of the water bottle, you'll see that it has not the hydro flask, but the other bottle, the water bottle, the clear one, the plastic one, the single-use one. You'll see how many milliliters are in there. Milliliters are written in there because everybody in the world is going to understand what a milliliter is, right? That one has 500 milliliters. It also probably has 16.9 fluid ounces. Yeah, because fluid ounces is what we would use in the United States. You know how you go to the cafeteria at school and you get like a pint of milk, or you can get a gallon of milk or a quart of milk. Those are all English measurements. Those are used in the United States. Everybody else uses the metric system but us. Unless, of course, you're a scientist, a doctor, a physician of any sort, a nurse, you would be using the metric system. But when it comes to like cooking, you measure in cups, you measure in tablespoons, teaspoons. People in other countries are going to use grams. So yeah, 500 milliliters for that, probably 16.9 fluid ounces. Like I said, you know, when you order a pizza, you get a 2-liter bottle of soda with it. So the metric system is something that's used in other countries as well as here in specific fields. So degrees Celsius is one of those measurements in the metric system. Alexandra, I would have to look that up. I would go to YouTube and find the answer to that question. Yeah, Ashton said his aunt is a scientist and she had some red stuff in a Petri dish, and it turns out that it had bacteria, and yeah, after it was in the incubator, absolutely, because the germs from your hands cause the bacteria to be there. Let's do an easy one. This is used to make things look larger. Type in the chat if you know what it is. Good, Jazz. Yeah, magnifying glass, good. Okay, so the magnifying glass is used when the object that we're looking at is too big to fit under a microscope. So you can use a magnifying glass to make it look larger. You guys used microscopes last year. You used compound light microscopes. The reason why it's called a compound light microscope is because it had more than one lens, so it's compound. And you also had to turn on a light to let some light through the specimen that you were looking at. So that's a compound light microscope. If something does not fit under there, because remember you put the slide onto the stage and there was the objectives over it, if something that you want to look at is too big to put under there, you can use the magnifying glass. What would I use if I want to look at things out in space? Would I use a magnifying glass? No, I'd use a telescope. Good, good. So the telescope can enlarge things as well. Awesome. Okay, one more thing here. Let's say you have abuela in the kitchen, right? Abuela may use these. Does anybody know what it is? It does grind. You do grind things with it, yes. It's called a mortar and pestle, right? So maybe you're grinding herbs or whatever it is. Scientists can grind soft minerals, right? You don't make the spices with it, Tyler, you actually grind them, yes. Okay. Sometimes, you know, chemists, there would be like pill forms of things. If you wanted to grind those down, that's what you use, a mortar and pestle. What else I have in here? I don't know if you're going to be able to see this. It's clear. You can't really see it, can you? Does anybody know what this is? You put your specimen on it. This is a slide. Now, that being said, what do you put on top of your specimen? Yes, okay. So I don't have the cover slip in here right now. I don't know why. This, actually, I do know why. This opened up, and because it opened, the cover slip fell out. But the cover slip is smaller, and it's square. And so what you do is you put your specimen on top of the slide, and then you take your cover slip and you drop it at like a 30-degree angle, and you create your mount, and then you can put it on the stage of the microscope. Yep, so slide and cover slip, they come together, okay, to look at something under the microscope. Here it is. Okay, I have two of these. These do the same, similar things, the same thing, but they're two different ones. So the one with the black top and then the clear one. Anybody know what these are? Squeezers. Squeezers, I like that, Alexander. Okay. This one here is a pipette. Absolutely, this is a pipette. This one here would be considered a medicine dropper, right? So if I had liquid medicine that I needed to give, you would take the bulb, the top part of it, squeeze it, put it into the liquid medicine, let go of the squeezed part, and the medicine will be drawn up into the eyedropper. The same thing happens with the pipette. However, the end of the pipette is different than that of the medicine dropper. But you should have used these when you did the penny lab, where you put droplets of water on a penny. This is the pipette. It's not a squirt gun. We don't use them as squirt guns. We use them in the lab, and we are very safe when using these. One thing I don't know if I said earlier about lab safety, a few people wrote in the chat that it was extremely important to read the directions and follow directions. Absolutely. You need to read the instructions or directions first before doing anything in a lab. Okay, make sure you have everything out that you need. Read through those instructions carefully and fully. This is the pipette, and we have a medicine dropper. This is the last one I'm going to do today. Does anybody know what this is called? And remember, we saw a beaker already, so it is not a beaker. But you'll see many chemistry, not chemistry symbols, chemistry pictures with this in it. A magical holder of liquid science. It starts with an F. F is in Frank. Yes, Travis, good job. This is a flask, and you can put liquids in the flask, right? And there are measurements on the side of the liquid. Remember, those measurements are not completely accurate. If you want accuracy, you're going to use your graduated cylinder. This is actually called an Erlenmeyer flask. It's a type of flask, the fellow who created it, but this is a flask, and we use it to hold chemicals, right? And did I tell you guys about these? What are these? Yeah, safety goggles, safety goggles. Okay, so that's a lot of the tools. It's not all the tools that I have, and it's not all the tools that you guys are going to learn about, but as you go through Module 2, you're going to see that there are other tools listed there for you that you're going to need to know. And you will be doing labs once we get back to school. There are some labs built into the program. You don't need the lab equipment for that, but there are labs built into the program, and we will be doing labs when we get back to school. Does anybody have any questions? Anyone? No? Okay.